Hello, everyone, and welcome back to Man Watch Required, the inspection podcast that sheds a little light on the inspection industry while having fun at the same time. It's kind of our goal to share some information and some of our experience and make it fun at the same time. You're here with Scott and Frank again. Last week we jumped into piping. Kind of a piping life cycle was the vision we had for it, and our thoughts were we could cover this all in an hour, but we ended up rambling on for too long, and we're going to have to make this a part two, I guess. What do you think, Frank?
I think the further we go into this and the further we actually scrutinize exactly what we do, almost everything could at least be an hour episode, right? I think we might even get to part three, possibly, depending on how far we get today. Our podcast tracker / inspection board, or whiteboard, sorry, is pretty full today. Scott, just kind of going through before we hit record here, there was a few things that we wanted to recap from last episode. Why don't you kick us off with that?
Yeah, I think that's a good way to start it. If anybody didn't catch the first episode, maybe you want to go back and give that one a listen. But kind of what we went off, we started our piping life cycle, and it starts in the fabrication, obviously, and we basically got to installation, not even quite installation, so that's where we'll take off to today. So just to recap, one of the big points we made, and we kind of beat that one to death, is the CAP, the certificate of authorization permit that our regulator issues. And one thing just to keep in mind with that is the fabricator has to have one. The repair or installation contractor, if that's the same company, great. If it's somebody else, they will also have to have a CAP for installing that piping, be it welding, mechanical assembly, whatever it is they're doing. And then the owner's also going to have a CAP as well. That may be for fabrication for themselves and installation, or it may just be their owner user program. So there's a couple of things to keep in mind for that. And that's an Alberta requirement that ABSA lays out for us. So you'll notice that we kind of reference ABSA a lot. That's our regulator in Alberta, and we kind of talk about the construction codes and a little bit over and above some of the requirements we're asked to meet in Alberta.
Yeah. Well, along with that, one thing that I did want to touch on is also B31.3 does have a tubing section in it. I said I didn't. I wasn't 100% sure if it was in there or not. Never really paid attention to it, but it is paragraph 315, and just the general nature of the way 31.3 is written and 31.1, like it's pretty easy to read and track stuff through, but you can also kind of get caught because there's also a K315, but it also pertains to tubing, and you can kind of get caught depending on which section you're reading. You might read the wrong requirements, so make sure you're in the right section of the code when you're looking stuff up. I just thought I'd throw that in.
Yeah, right. And I think that's maybe why our regulator clings to a little bit. It's and I think all we want to say about that is don't forget about the tubing. It doesn't always need to be hydro tested, but just look at the application and don't forget about it. There's a lot of cases where it should be subject to the same scrutiny as your piping.
And maybe the reason I specifically brought up Section K was you're not allowed to actually use a flared type joint in tubing under that. And it's high pressure piping, I think. Yeah.
Sounds right.
So, like, obviously it wouldn't, but I think more realistically, it's not leaning towards instrumentation tubing. It's actually leaning towards like tubing. That might bigger than instrumentation stuff, like a 2-inch tube or maybe half-inch and up.
Yeah, tubing's not always just small diameter stuff that you can bend around and put compression fittings on. A lot of time it's the same size as your piping. So yeah, you can get large too and see high pressure. So that's something to be aware of there. But yeah, we were kind of alluding to the small bore piping that you'd bend and use compression fittings. A lot of that stuff does have to see a hydro test too. So just make sure you're aware of what you're doing there. We did kind of kick around category D a few times, and we didn't really explain what that is. So maybe we should just touch a little bit on the 31.3. That's one of our main construction codes for most of the piping in the plants, but it does have some different fluid services and different construction and inspection requirements Mainly during the fabrication stage. 31.3 is a construction code, so it doesn't get into the, inspection and in-service condition. But I think we should maybe touch on some of those fluid service requirements, just make people aware of that.
Sure. Where do you want to start? Do you want category D? Easy?
Yeah.
Pick the low-hanging fruit?
Yeah, I guess that's the one we talked about yesterday. I mean, it's D for don't hydro, I believe is what that's about.
Not according to ABSA.
If you listen to the last episode, we do in some instances have to hydro test that. But drain is a good way to remember it if you want. It's basically your stuff that drains to DO or to sewer or something like that. A lot of times there'll be a valve in line and it can be isolated, but that's essentially what it is. And there's some design requirements around that, but that's one thing to be aware of. There'll be different fabrication requirements around material, around your NDE acceptance, things like that. Mm-hmm. What else we got? Maybe we'll just start creeping up to the more severe. I guess would normal fluid be the next one up the chain?
Yeah, sure. And this is going to be typically what 98 to 99% of your units or plant is going to be.
I'd say so.
Falling under, right? So that's something to keep in mind as well. And then M is going to be toxic. There's also those are kind of like the three main ones. There's also elevated temperature, high purity, and high pressure, like we kind of mentioned before. And those will each have, like Scott said, their own kind of construction requirements and stuff like that the fabricator, the owner, and everybody is definitely obliged to follow when constructing to those codes.
Yeah, exactly. And there's a severe cyclic gets kicked in there too. It's not really a fluid service, but it is something to be aware of. And it does have some different fabrication requirements and inspection requirements. So I guess the point we're trying to make there is the fabricator needs to be aware of what service it is so they can do their NDE and fabricating appropriately. And then the owner has to designate it, and they have to designate it to the proper fluid service. So just a couple things to be aware of there. I guess on that, it's somewhat related to the cap and the different fluid services and whatnot. I did want to mention very quickly, but not get too much into this. I see we don't have it on the whiteboard anymore. It must have got scratched.
What happened? What did I miss?
Just the fired heater coils. I wanted to make note of that. That's a lot of times those are constructed to 31.3 or maybe even Section 1, depending on what the fluid service is. That's an additional line item on the cap. So if you get into that territory, just make sure that's there as well. But I think we'll spend an hour one of these weeks on heaters. There's a lot to talk about there.
That's why I took it off. I wanted to save that gem of information for the fired heater podcast, right?
We can cut that out.
Actually, one thing I did want to say, vibrating service, right? Where do you think that falls in under that?
Well, I'd say your severe cyclic kind of points you in that direction. So that would be something to look at there. And if you do go to your ND acceptance tables, you'll see it's broken up into three sections. I think it's three. I think M and normal are together, and D and severe are on their own, something like that. But yeah, you'll see that the severe is pretty strict on cracking and elongated indications, things like that. There's really no tolerance. So that's kind of pointing you towards that.
Cool. All right, so I think the last thing from the recap is going to kind of be some acronyms that we might have mentioned, or at least we think we mentioned. We did go back and re-listen to that episode just to make sure we're trying to catch everything when we say we'll catch that next episode. Yeah,
or I think half the acronyms we spell out what they are and half we don't. So it's either we just go one or the other. We don't tell you what any of these are, or we try to explain them all. So maybe we'll try to explain them for now.
Yeah, well, one actual listener put a review out there and said you need a notepad, and I don't know if that's to fact check us or to remember all the crazy crap we say. So let's start out with our first one, MDMT.
Hopefully it's not the fact check. No, I'm worried.
They're always fact check.
Okay, yeah, MDMT. So what? I don't know if we mentioned MDMT, but I did mention CVN very quickly, like so quickly you can almost not even hear it. So that's just your Sharpie testing, like your Sharpie V Notch. And we thought we'd pull MDMT into that, minimum design metal temperatures. So just really quickly what that is, like the Sharpie V Notch is a test they do for low temperature impact properties. And essentially what it is, they'll take a sample of the material, cool it to a really sub-zero temperatures. They put a notch in it and then they smash it with a big hammer. and it measures how much energy it absorbs, and it gives you a rating, and usually in joules or something like that, in energy anyways, what it can absorb. And that's, where am I trying to go with this? That'll give you a rating down to a certain temperature. So piping, for example, a lot of our plain carbon steel fittings are good down to minus 29. Once you start getting below that, you have to get material ordered with this Sharpie testing done. So that's kind of where we want to go with that one, I think. I don't know if we want to get too much more into it. Your construction codes will lay out when you have to have that low temperature material. Like A106B, for example, is something above that minus 29 threshold. You get into the A333s and things like that. They'll all come impact tested. So that's just something you want to be aware of, and when you have to pull that material in. But just to give you some info on those acronyms of what they are.
That's not a bad point. Like, I remember working in a fab shop and like building stuff, and like I just knew it was A333, low temp. That's all, low temp, right? Yeah. And it wasn't until I started getting into QC and in-service inspection, I started kind of getting into that kind of stuff. So it is pretty interesting, and for sure, especially for our climate or just services, right?
Service conditions for sure. Yeah. You're
gonna want that for sure. So something to be aware of. Good.
Actually, sorry, before we jump ahead, even your welding procedures, be aware of that too. They fit in the same way. So if you got some low temperature design material that needs to meet those requirements, your welding procedure actually has to meet the same requirements. So they'll do the same thing. They'll take a sample, freeze it, smash it with a hammer, measure it in joules, and that's just something to be aware of reviewing welding procedures. Make sure it's registered with that low impact if required, right? You got to check your construction codes and a few avenues there, but that's kind of what we're alluding to there, and maybe on another episode on welding or fabrication or something, we'll go a little deeper into that, but I think that's good for now.
No, that was a good catch. I think that's actually why we put that on the board in the first place, right?
I think so, but I didn't put enough notes, so we almost missed it.
Next acronym, we were talking about NDE and NDE certifications, tech certifications, stuff like that. We mentioned CGSB, Canadian General Standards Board, right? It's kind of what we're certified to. It's the general standard, I guess, right?
Yeah, it's a pretty self-explanatory, really. It couldn't be more vague.
Yeah.
But that's, for any of the American listeners that are familiar with the S&T, TC1A, those things, that's kind of our equivalent we have here, and it's really only a Canadian thing, so you probably won't see it anywhere else. But we did mention that, and that's what we have. That's kind of our certification body. Now, along with that, we didn't mention NRCan, but NRCan is kind of the government regulator, if you will. So they issue the certifications, put on the examination and whatnot. But the CJSB writes the standards and they make the standards. It's, I guess, similar if you want to think of it like materials. ASTM kind of writes the standards for materials, and then ASME adopts them, puts their essay on it. It's the same kind of thing.
Scott, you didn't explain what NRCan was.
National Resources Canada is what that is. So
yeah,
right. I think I explained what it was. I didn't explain what the acronym was. So there we go again in our acronyms recap, blowing right through them.
Okay, we do have CAP and AQP written on there. So Scott did touch on that right in the opening there. Certificate of Authorization Permit is CAP. AQP is your actual authorization permit, right?
Yeah, so CAP, I think we did explain on the last episode, but we just thought we'd lump a couple of these things together that are all essentially the same thing, but you kind of need them all. So the AQP is actually an Alberta quality program, or you may even hear like approved quality program, same thing essentially, but it is an Alberta thing. So that's on your CAP. The CAP is the permit, the AQP is the number that you have listed. So you'll see on your CAP like AQP number, it might be 4 digits, 3 digits, 5 digits, depending on how old the company is, I suppose. And then QMS is another thing I think we kind of rattled off quickly too, but that's your quality management system. And that's basically everything all bundled up together as far as what your company does and the measures it takes. And that's something everybody has to have, whether you need a CAP for doing pressure equipment work or not. You're going to have some sort of quality management system in place for construction, repair, inspection, any kind of avenue of this industry that we're in.
Yeah, no, that's a great way to explain it, and actually was it segue or leads us into
I like segue, yeah. I like that word.
I don't like it though, because it's one of those
I think that's why I like
little ride around things. I don't know. Jesus. I'm not into them. I'll leave it there. So then that kind of leads us into installation inspection and starting to set up our corrosion programs. So again, since we're in Alberta, our regulator does have a standard, or I guess.
Yeah, I guess regulation may be a good way to call it. ABSA regulation.
Touche.
Yeah, sounds about right.
No, that's right. Yeah. And that document is AB 506. Now it states that owners of pressure equipment piping must have an integrity program. It works in tandem with API 570 and the National Board Inspection Code Part 2. NBIC would be the acronym for that one. And, we're hoping that this is an in-service inspection podcast. So like API 570, which is the American Petroleum Institute, they put out a standard for the inspection of in-service piping, which is API 570. Pressure vessels is API 510, and that's one you hear a lot about. National Board is there as well. ABSA kind of gets a little picky. I don't know, like some stuff they really go with National Board and they follow it to a T, and then like other areas, it's kind of like, yeah, you can use something else if you want.
Yeah, that's interesting. If you didn't go there, I was going to try to jump in there. It is kind of interesting, and I don't know if they like API National Board or they don't like them. It is interesting. Around the inspection space, they seem to have no problem referencing API National Board and good engineering practice and whatnot as, good examples to build an integrity program. But when you get into the repair space, and construction's not a question because you have your construction code, so that's its own thing. But when you get into the repair space, when you're doing repairs or replacing piping your equipment, they are kind of specific on not using the in-service recommended practices of API and National Board code. So it's kind of a weird, I don't know where the line is drawn type of thing. And then it's one of those situations like temper bead and things like that where the National Board has great info on that, and that seems to be okay to use, but most everything else it says isn't okay to use. So that's just something to be careful of too. More so in the repair space, I would say on the inspection side, they're pretty good with pulling in information from API, National Board, and some other external resources.
Yeah, no, definitely. So that's something to remember and kind of be aware of, and dig into what exactly. Which codes they say shall and should kind of.
Yes,
right?
Very scary words. Actually, you just reminded me of something, and we have it written on the board very small back in the recap. The shall and should remind me of this. So the exemption order, that's something, sorry to go back a little bit here, but I think this is an important point. The exemption order, we blabbed about a little bit, but didn't really explain what it is. It's essentially exactly what it sounds like it is. It's a document that'll exempt equipment and piping and various things from the Safety Codes Act, from any kind of regulation beyond the construction code. So there's a lot of outs there. There is an AB 529 document, which is essentially a user guide. So if you pull up the exemption order from the Queen's printer, it's very hard to read. It's really lawyered up. It can be very confusing. So ABSA's put a document together, a regulation, the 529. So it's pretty good, taking you step by step and explaining it a little better. And something I just want to caution people on with that one, typically they'll have, whatever you're trying to exempt, say it's a piece of piping, whatever it is, you find your category and they'll have typically 3 things listed, 1, 2, 3. So you have to meet 1, 2, and then it'll either say or 3, or it'll say and 3. There's a very big difference there. If it says 1, 2, and 3, you have to meet all 3 of those to be exempt. If it says 1, 2, or 3, or 4, however many are listed, you only have to meet one of those requirements to be exempt. So that's just something to be very cautious of. That a change in one simple word there makes a big difference.
No, okay. So I'm not supposed to just read the one that I want to see and then say it's exempt.
Yeah, exactly. You don't just find the one that works and go with that. See if it says and or. Very, very big difference there.
And to make sure your thumbs are on the edge of the page so you see all the words, right?
Yeah, of course.
Yeah. Okay. No, that was a great point, and we did actually skim over that. I think we kind of got lost in that with the acronym, so we're pretty excited to jump ahead.
Yeah, I think so. We're trying to get out of this episode or part one of piping life cycle, which we can't seem to get away from.
So we did reference that API 570 and National Board Part 2 are recognized for the inspection of in-service equipment and piping, piping for 570 definitely. API also does have line classes similar to B31.3, and I think the kind of approach we're going to take onto this is maybe a new facility or an existing facility that doesn't have a program, integrity program in place. And even though we just got through saying that AB 506 requires owners of pressure equipment to run and maintain a quality program, a lot of smaller companies and there's a lot of facilities that do fall within gray zones where the owner operators might they might agree that they have to do it, but it's always an uphill fight to kind of get them to do it. And the type of facilities kind of like that are typically, you know what, I don't know if I want to say them because there's only like 2 companies that do it.
Be careful.
Yeah. I still want to go and work there, right?
Oh, maybe we can set up an integrity program for them. There we go.
Trust me, I've been there.
What do you mean that's not free?
Yeah. So a good place to start if you don't have information such as CCDs, corrosion control documents, or CCMs, corrosion control manuals that typically larger refining facilities or upgrading facilities have, because it's definitely in their best interest aside from being a jurisdictional requirement for them to operate.
And they have the support staff too, right? I mean, maybe some of the smaller facilities don't have 20 or 30 corrosion engineers running around with the wealth of knowledge, so that's a bit of a difference too, right?
No, that's definitely a great point, especially a lot of the junior players and stuff where they have old wells and they're just pumping crude out of the ground and then sending it to a pipeline. It's like just 3 people on site. It's always bare minimum, and they do what they can for sure, and it's usually contracted out. And sorry, I don't mean to go off on another tangent here, but like usually when it's contracted out, a lot of the people doing that work, like it's getting better now because I feel like the industry's kind of recognized this, but the person doing the circuitization, and I'll get into that in a second, but identifying where CMLs go and identifying what type of maybe corrosion mechanisms or potential within the systems we're assessing, they don't always have the experience. And that's kind of where these larger facilities where you have a wealth of resources to kind of pull from experience and knowledge to kind of really get these buttoned down. So a lot of these smaller facilities, like it's a frickin' mess. And a lot of times if they switch inspection companies, those documents don't get transferred over and you're starting from scratch. So that's kind of where I guess this mind frame is coming from. It's either going to be commissioning standpoint or you're showing up to a new site that's already in service and you're going to set up a corrosion program for them, which does happen quite often. And actually, I like that, doing that kind of work. It's pretty fun.
Yeah, that's a good example, and I think maybe we'll talk about both our piping life cycle as far as new piping being installed and where that goes, and then places that don't have anything are looking to get something, or a change of ownership too is another big one too, where not everything gets handed over properly, and like Frank said, you're kind of starting from scratch. One thing I will caution anybody listening that doesn't have an integrity program and maybe thinks they should, one thing to be careful of, and not so much for setting it up and piping CMLs and whatnot, but once you get somebody contracted in to do in-service inspections, they have to have a cap for that as well too. So going back to the old cap again, you can't just bring anybody in with a 510 and ABSA in-service designation to do some inspections. You have to, as the owner, have an owner-user program that allows you to do in-service inspections. Or if you hire that contract company, they have to have their own cap to do in-service inspections. No different than the company that's building your piping or pressure vessel for you. Same thing. So just be aware of that. You could end up with a bunch of void inspection certificates, really.
That's a really good point, and I like how you wanted to go with the new construction and then go into the existing. I also really like how you touched on changing a service. I do think, however, that's more applicable to actual pressure vessels as opposed to piping.
It is. I do have a story we could share about some change of ownership thing, and it's more around the loss of records type of thing, and starting over, and how inconvenient it is not to have your nominals. I think we touched on that on part 1 about maybe even having the fabricator do it in some instances, but just the differences of whether you have that info or not, and what kind of mess you can be in, or maybe sometimes it can be great. You get handed over some good inspection records and you carry on, right where you are.
Yeah, well, yeah. And also, Scott and I are available if you don't have a integrity management program.
But don't look up our cap. Trust us, we have one.
Yeah. So basically, like I was saying, API does have their own type of line classes, and they do, for the most part, align with what ASME has there in B31.3. Class 1 is going to be like really bad, like immediate emergency to health and safety in the environment. Class 2 is going to be like your normal fluid service. It's going to be the majority of your unit or plant piping. Class 3 is typically characterized as flammable liquids, but ones that don't really vaporize too quickly. And then Class 4 is going to be your Category D equivalent, where it's going to be non-flammable and non-toxic. And of course, you're going to inspect these accordingly, right? Like, you're not going to over inspect a Class 4 or a Category D piping just to inspect it, right? And this is kind of where we're going to start getting into it, where you do want to streamline your inspection strategy to not, save money, but also save time and freaking effort, because like, once you get into it, you're going to start honing down on areas, especially within specific systems where corrosion is consistently occurring or can happen because of process upsets. And, you're going to be able to kind of be better equipped and better prepared to manage these situations, or even in some cases kind of give them a remaining life of it, so then you can limp it through to your next outage or turnaround situation where you can actually replace it or upgrade it. And we will kind of get into replacement and upgrading of materials, I think, later on, if we have enough time, hopefully.
Yeah, we'll see how long we ramble on here. I like the comparison you did with the construction code and the API classes. That's a good way to look at it. Like, Category 1 being your Category M comparison, that type of thing. That was really nice. I liked how you did that. And it was a good point on the how much NDE you're going to throw at these things. There's a cost and time and all that thing, but there's also a risk factor there too. I mean, do you really need to send an inspector out there to inspect a whole bunch of, your Class 4 or Category D piping that you really know you're not going to find anything? I mean, you're putting somebody into a live plant to go do a bunch of inspections that they, maybe don't really need to do. So that's just something to look at. I mean, most of our catastrophic failures are due to piping systems in some way or another. So that's just something to think about as well.
No, definitely. And that's actually a line out of 506.
Might be where I got it from.
Yeah. So let's go back to, let's rein it in now that we know that there's some, I don't want to say alignment, but there's parallels, I guess, between 570 and the ASME construction codes B31.3 that you can draw from. And if you don't, Scott and I were actually talking as we were kind of just writing out the framework for the episode about setting up integrity management programs for smaller companies where they don't exactly have a corrosion control document that you could reference and kind of see what's happening. So you would default to your API classes, right? What kind of category fluid or system do I have here? And that's going to start affecting how you're going to inspect it. So before we get into that, I think that's maybe hopefully 10 minutes from now. Let's jump into installation inspections. So we fabricated it last episode. We're partially installing it. I know we touched on some field fabrication. What do you think, Scott? What kind of things should we be looking for during our installation inspection? I'll get this out of the way first because I know Scott's going to want to talk about it for another hour. Construction records, right? And going through the documentation. Go through it as required, right? If you want to audit it, spot check it, go through it. If they're doing some final tie-ins in the field while you're kind of just walking around checking things out, you're going to eventually probably end up signing off on those packages anyway. So, make sure, make sure you just do a check on it.
That's where a loose signature Frank comes in. But no, that's a good point. The construction records, this isn't the time to be scrutinizing them. At this point, they should already be signed off, certified by an owner inspector. If you start digging around in that stuff too much, you will find problems. Hopefully not big ones, but you will find them. And, there may be no benefit to that. The biggest point, I think, with that is making sure you have them, making sure they're filed appropriately, MOC closeouts, those type of things. Project closeouts, whatever you got going on. But the biggest thing is just make sure you have those records, make sure you can find them again. So, when you go to repair this thing in 10 or 20 years and you need that information, you can't find it. Well, then what good was it in the first place?
Yeah, no, that's good. And
that's all I'll say about that. I'll leave it alone.
Yeah, I just want to get back to that nice little cut you gave there. That was good. I don't want to say anything. I just want to leave it there, right? My signatures aren't loose though. Get out of here. Some things you're going to want to look for is you're going to want to make sure that the piping is properly run, right? You want to check its supports. You want to check alignment, right? Just visually, like you don't need to go and take a tape measure and start measuring off the side of the columns there, the pipe rack, to see if everything is centered. You got to trust that the construction guys and the quality control have done their job, but take a peek, especially in these upper high lines or pipe racks. You want to make sure your piping is properly run. You want to make sure your shoes are actually kind of centered, right? There's going to be some thermal expansion, most likely not contraction, but we've seen these pieces of pipe, they grow too much and all the shoes are just aligned enough where that whole piece of pipe moves and it slams directly onto the I-beam.
Yeah, it falls right off the support. Now you got a bunch of anchors where you didn't want them.
Yeah. Another good thing to look for is like dummy legs, right? Dummy legs and weep holes. You want to make sure, there's not going to be too many. Well, weep holes are pretty much specific to, I guess they're on repads and dummy legs, but I'm going to be more talking about on the dummy leg side. You want to make sure dummy legs do have weep holes. You don't want condensation and stuff accumulating in there. That's going to contribute to corrosion. You want to make sure that your pipe supports and dummy legs are sitting flush on the associated supports they're supposed to, right? You don't know when stuff grows, the lines sometimes have a mind of their own, right?
Oh yeah, that's a good point with all the pipe supporting. That's one of those things, like piping in general, we think kind of gets overlooked to some degree. But if you want to microscope it down to piping itself, like the pipe supports are something that always get overlooked, and that's, you could argue, is the most important aspect of your piping system. I mean, as part of your walk downs, like Frank said, you're going to want to make sure your supports are sitting on something. If they're not, they're obviously not doing their job. And then around dummy legs, and Frank touched on condensation. I mean, if they're insulated too, that's a big factor as well, because then you have a potential entrance point for moisture and condensation and things like that, where you got potentially a hot piping and then a cold dummy leg that's going to be subject to the whatever temperature you have in the atmosphere. So those are some really good points. Like don't forget about those pipe supports, shoes. Make sure you have guides where you need guides, anchors where you need anchors, and you don't want to end up with a big expansion loop sitting on the steel and your pipe and your shoe or dummy leg or whatever is right up against the I-beam. Now it's in the wrong spot and it can't move. So it's a double whammy there. Yeah,
and then you're causing unneeded stresses, which depending on your service could cause issues, right? Mm-hmm. I do like how you brought up the temperature gradient of possible dummy legs and stuff like that. Like, on a side note, like, yes, like even on vessels, like we've seen corrosion on certain nozzles and stuff like that, and you're like, why the heck is that happening there? We don't see anything else. What ends up happening is you go out there and the freaking nozzle isn't insulated or something, and the process is a lot hotter, and that temperature gradient is enough to cause some sort of condensing acid or something, just specifically within that zone that's exposed to ambient temperatures, and you get screwed over that, right? So that's good stuff to actually walk around and do. I know that's more predominant on vessels, but it is actually fairly prominent on piping as well, where you have dummy legs and stuff that are uninsulated. Maybe for the little birdies as well, you might want to check that the dummy legs might have a cap on it or anything like that to prevent wildlife from going in. That's a minor issue, but that's just something to think about. Actually, PSV outlets, pressure relief valves or pressure safety valves, the outlets, especially if they vent to atmosphere on the larger diameter ones, you don't want birds going in there. And I could probably count on more times than both hands of fingers or where you found freaking birds in a PSV outlet, right?
Oh yeah, no doubt. And you don't want to be launching a frozen turkey across site either when those things let go. So, but yeah, that's you touched on weep holes earlier too, and that's something you want, especially if your PSV outlets go straight up, which a lot of times they do. You want to make sure there's a weep hole in that so it drains. That's the last thing you want, is that filling up with snow and water and freezing. Then all of a sudden your PSV is now a blind flange or something, right? So. But that's a good point about the wildlife too. I remember a commissioning job we did a few years back, and we had a bunch of, they're essentially like blowdown lines type of thing. There's 3 of them, they went straight up, and they actually fired off like rocket ships when they were operating. So, you're not too worried about a bird getting in there at that point. But one of the things we did, and I don't know if this is the best idea or not, but we tack welded a bunch of like spikes around the outside of the piping. So it was like 6 or 8 inch piping, something like that, went straight up. Something similar to you'd see off of a PSV discharge, same kind of idea.
Yeah.
And we had tack welded a bunch of spikes around there to kind of deter the birds from landing on there, or maybe they'd get stuck. I don't know, but I don't know. That was a kind of an interesting thing you don't see a lot of times. A lot of times you'll just tack some screen on there,
yeah.
Right? And it depends on what kind of flow you might expect out of it. But tacking some mesh or screen on there is not a bad idea either. Keeps them out of there.
Yeah, and maybe even a better configuration of having the outlet straight up, like it could possibly 90 and go out horizontally, right? And that'll prevent a lot of, moisture accumulation from rain, snow, stuff like that. But Scott is right. That is a really good point, is you should have a weep hole on those PSV outlets venting to atmosphere, and that actually should be a part of your check. That's a little bit down on our list here, but who cares, whatever. While you're walking down the piping, check the frickin' pressure relief, right? That's part of your piping inspection, is to verify overpressure protection with a PSV or a PRV. You want to check. This is going to get back into some other stuff too. There's something here. CRNs. CRNs
it's
on
eating away
PSV.
at you. Let's hear it. Let's have it.
Okay. What do you think? What if you found a PSV in the field, right? It's got its nameplate on there, but the nameplate doesn't have a CRN on it.
Ooh.
Right?
What would you do?
What would you do, right? But then they do have service documents with a CRN on it. Like the service records have the CRN.
Well, I mean, is a PSV scrutinized similar to a vessel where it's got to have the nameplate and those registration numbers on there? I would say so, but I mean, are you going to shut down the plant and rip that thing out of there? Probably not.
No.
But it would be definitely a deficiency you'd want to note, and at the next servicing interval, you'd want to get that either replaced or the nameplate updated, or whatever's going to work for you.
Yeah, no, that's exactly the right answer. But
that's
just something that I came across in my junior inspection years that I kind of just thought about while we were jotting that down.
Right, and I would feel a lot better about having that documentation that has the CRN number on there. So at least you're pretty confident that it's registered. I mean, at least it's in one place. If it wasn't either place, you definitely want to have that as like a A or priority 1 deficiency type of thing. That let's get something done about this.
Yeah, realistically, I don't know if they could. Probably couldn't put a nameplate on it while it's in service, but have it documented as long as you have it. But if you do have a PSV or an PRV operating with no CRN, you need to call the manufacturer and check, or it's essentially illegal, I guess, right? You're not allowed to use it. It really is, yeah. So that's kind of a frickin' rabbit hole we went down, but
it is, and I think the point we're making too is some of these things, just because you find a deficiency doesn't mean you have to go shut the plant down necessarily. And if we are getting back to our installation pipe part of our piping life cycle, and that's the stage you find it in, you definitely want to address that before you commission it, no doubt.
Yeah, no, definitely.
If it is in service and it's due for servicing in a year or something like that, then that's definitely something you would want to have as a deficiency and get corrected when the PSV is out of service. So just kind of see what situation you have and address it accordingly.
Yeah, no, definitely good
What
point.
about the code stamping on the PSVs? Because they are scrutinized to that as well. Typically a U stamp, I guess, like a pressure vessel. But what about if you had some boiler piping or right off the side of a boiler, for example? Would your U stamp be sufficient?
No.
Or would you be looking for the UV on that one? So, I mean, that's just something to be aware of too, some slight differences. It just has to be tested with steam, and it's fabricated a little differently. So another one of those things to kind of watch out for too. Make sure you're the right application. If you're, on a steam or boiler system, you want to make sure you have that UV certification.
That's a really good point. There'll also be a national board stamp on there as well sometimes, right?
Yeah. Most of the PSVs will have that too. I think because a lot of them are fabricated in the United States or out of country. So that's kind of getting back to our part 1 episode where we talked about how the national board authorized and certified piping as it came in. Same thing for pressure vessels and PSVs and things like that. Same idea. They'll certify, and then ABSA accepts that.
Yeah, and I would actually encourage unit inspectors, contractors, maybe not so much, but definitely owner user guys, go and download the brochure of the pressure relief device that you have. The manufacturers have them all online, and it actually tells you what all that jumble of numbers means in front, right? It's all internal component grades and stuff like that. And when you're getting a PSV service and stuff like that, that's definitely stuff you want to check on the service report or on the installation report, actually, to make sure that your components are going to actually meet your service requirements, because once it's in service, there's all sorts of issues that can happen. If you got a block valve on the inlet side of it, it might not be able to isolate, and then you can't actually remove that device from service, and now it could potentially be corroding or rendered inoperable because of the material mismatch with the service, and then you're in a whole whack of trouble.
Sounds like you're speaking from experience here, Frank.
I've been on the back end of it. I haven't, you know what I mean?
That's a good point with the block valves too. I mean, getting back to our steam piping or more so our boilers protected by the vessels. I mean, that's one where you're not going to have that option, because if you have a block valve in front of a steam PSV or a boiler pressure relief, you've got a serious problem, because that's a code violation. You can't do that. Not to say that there's not a lot of facilities that have that have just kind of been adopted in, but that'd be something you'd want to have on your MOC list to get addressed whenever the budget and schedule allows for it, type of thing. But yeah, a lot of times you can't get them out. You can't isolate them, and sometimes you can. So you just got to be aware what kind of situation you're going to be in.
Well, yeah, a lot of times too on your 31.1 piping, they're welded valves, right?
Yeah, exactly. They could be, or I mean, the PSV on your piping system could be protecting a vessel or several vessels too. So now you're going to be leaving them unprotected. So you got to be very careful with what you're doing there, and that's typically why a lot of the times they're part of your turnarounds is when you service those things.
Yeah, and I guess maybe one final note on these pressure relief device things is checking their setting and ratings, checking the pressure setting, capacity, and stuff like that, especially on the boiler side of stuff. You definitely want to know that. But within your piping systems on your plant for your normal kind of B31.3 stuff, you're going to want to kind of make sure that your PSV set temperature or set pressure, aligns kind of with the equipment as well, because a lot of times you may have there are some sirens in the background if you can hear or not hear.
I think they're here for you.
Yeah, Scott was very concerned with that. I could see on his face, so I thought I'd make mention. But you want to make sure that your pressure relief device is actually kind of set. It's never going to be set to what your piping was kind of designed for, unless that device was set for that piping. It's usually going to be set for a piece of equipment within the system. Is that a fair statement?
Yeah, I would say so, because a lot of times your piping is going to be rated a lot higher, which can even give you some grief too. I got a story we'll share if we'll see if we have time and get to the repair kind of end of your piping life cycle. I'll maybe bring this story up if I think about it. But yeah, it's going to be more reflective of the equipment it's protecting, not necessarily the piping system. Sometimes it will be a relief just for the piping system itself, but a lot of times it will be, like Frank said, it's going to be, the set pressure is going to be equivalent to your, your pressure vessel or boiler or whatever it's protecting.
Yeah, and that might be something to kind of maybe get into either on its own PSV episode, or maybe we can touch on it in the equipment episode.
Yeah, like I think when we get into vessels, that'll be probably a 3-part episode, similar layout to this. But I think that's something we'll have to talk about, even if we drag boilers into it. That's very important, is that overpressure protection. So that's something we could spend some time talking about for sure.
I would say bottom line, just figure out why that PSV is set to that temperature. Or sorry, I keep saying temperature. I don't know why. Set to that pressure, and it obviously it's going to have a capacity as well. You might want to check that, but that's some heavy calculations and stuff. If you're really suspect of something like that, get the engineers to do it. That's not really an inspector thing.
Yeah, absolutely. And it's, that's all part of your walk down, part of your commissioning. I mean, you want to make sure that things bolted up properly too, kind of getting into that portion of it. You want to make sure there's not a bunch of misalignments specifically on those PSVs. They're not really designed to have a bunch of that side loading on them. So that's something you want to be aware of. If at all possible, it's nice to see these things installed. I know I've worked on a couple sites where it's part of their PSV program is that the owner's inspector or the contractors or whoever, they watch the pipe fitters unbolt the piping, inlet and outlet, and then they also watch them install it, just so mainly for when you're removing it, if you do have some sort of movement on your piping, you can address it then. You may have time if you have to add it or take some piping out or whatever, and then it goes back in a lot easier. Or if you don't have time, depending on the system configuration, it's something you can note as a deficiency, and that gets added to the list for next time. So that's kind of an interesting method one of the sites I've worked at does.
We could go on so long on just PSVs.
I know. I was trying to get away from it, but
so many things kept popping in my head as you were talking there. I'll keep my mouth shut though. Okay. I do want to actually move on to something that I thoroughly enjoy. Matt, our friend, who Scott hasn't met yet, also thoroughly enjoys it. We have Scott and I are obviously the hosts of the podcast. Matt is the third. He's just had an extremely busy schedule, and he hasn't been able to come in. But this is something that he really loves, and I'm sure once we get him in, he'll want to touch base on it. But maybe we'll do a more specific episode when he's here and really dig into that stuff. We might have to, because this is a great topic, and I actually have a lot of fun doing this because you actually learn a lot, right? Circuitization of your piping system. So essentially, everything's fabricated, or as you're fabricating, we did mention some baseline readings last episode, which are essentially your initial readings to start your corrosion program. You can do nominal, but we did talk about the mil tolerances and how they eventually do skew your corrosion rates. We can dive into that a little bit more. That is a wholehearted conversation too that we usually have at the facility we work at with other inspectors. Yeah, it really is, and especially like your zero corrosion allowance type of systems too. That can really accelerate or decrease your corrosion rate. So that's something to be careful of too. And if you can get it at the new construction phase, where you got exact readings versus your nominal, sometimes that's a big difference, especially in you get into some thicker materials. That 12.5% adds up pretty quickly. So that's a good thing to get done right off the bat if you can. Yeah, no, definitely. And for those zero corrosion allowance systems, I guess, they're typically going to be made out of stainless steel. And you might actually, if most of the time you're going to be using some sort of program to document all this stuff, kind of like a database. But like if you put in the nominal thickness and then zero corrosion allowance, and then you go and take your baseline reading, and it's within that 12.5% of mil tolerance below the nominal, your system's whacked already, and it's going to start giving you errors or flags to go inspect it like 2 weeks in, right? And
already in the red right off the bat.
Yeah, story of my life, right? So the quickest way to get around that, I think, I feel like I'm lighting a fire with this, but whatever, is get an engineered team in and put that into your system and monitor it. Like theoretically, if it's got a 0 corrosion allowance, it's there for a reason. Like they think that material is going to be able to handle that service with no issues, right? And a big mistake actually a lot of companies make, this might be jumping the gun, is it's got the right metallurgy for that service, so we can inspect it on a less frequent basis, where I would say like, okay, let's inspect it normally for maybe like the first couple cycles, and if we actually don't see anything, let's start extending those inspection intervals out, which is something we will get into. I think holy cow, I think we're close to the 50-minute mark already. Depends depends on where we edited this, but our timer right now is showing about 51 minutes. So you're going to break up your piping systems into circuits, and essentially you could go from the most severe, like your API class 1 or your category M's, or which you're really not gonna have in your normal facilities, but
not a lot. No,
we'll say your category 1s or your category 2s, like your most severe ones that actually need attention. Like if something goes wrong with this system, it's an immediate emergency. So you want to start circuitizing these ones first. You can also start even with the process flow, which is actually not a bad way, and it kind of actually it can inherently lead you to your piping classes, because if you're in a refinery, you're going to have feed that's coming in at a relatively low temperature. It's non-corrosive, and then you're going to run it through a heater, and then you're going to start fractionating it or distilling it, right? And that's essentially after that heater is, or at the heater is where all your corrosion issues are going to start. And from there, it's essentially following the process, and you're going to you're going to have to make some sort of hierarchy of what's doing what.
Yeah, that's a really good point. And then it kind of alludes to your CML locations too. I mean, if you got your flow considerations, and if you got some serious erosion concerns and some elbows and things like that, that's where you want to have CMLs. But at the same time, you don't want to be inspecting every single elbow and every run of pipe either. You can over inspect these things, and then at a certain point it just doesn't get looked at anymore. It's just way too much data. And then like another point too is, don't forget the top side of the piping too, depending on the process and the surface that's in there. You could have some vapor site corrosion where it's all happening on the top and not so much the bottom. So that's kind of a thing that gets misled a little bit. I mean, a lot of these bigger facilities will have pretty extravagant integrity management programs, softwares they've created or bought or whatever that, will do a lot of work for you, and there's a lot of fail safes and catches there, where you'll have other facilities that have nothing in place, and you come in and you work off of an Excel spreadsheet, which is nothing wrong with that, but you got to be really knowledgeable, and you got to really know the plant well, and have a good communication with the operations and the process people to really get those systems in place and set that up for them. Otherwise, you're either just over inspecting because you have no other reason, like you just don't know the system well enough, so you're over inspecting it, wasting a lot of time and money, or you're going to under inspect it, and worst case scenario, you have some sort of disaster where you have a leak or something like that, and you have an unplanned outage. So those are just some things to be aware of, what kind of facility you're at and what they have in place.
No, definitely. And just kind of going through them, like, this is so general right now, like it frustrates me, and it frustrates me that we're already like near an hour, because I could really go off on a lot more of this. This is like the fun, this is where being an inspector actually gets fun for me, right? Like the documentation review and all that stuff, like the fabrication, it's neat, and it's fun work to do actually. Like I really enjoyed fabricating and like building mods, and then going up on the site and installing stuff, right? Like it's cool to see that life cycle from the construction standpoint, but this stuff is like the bread and butter, I guess, right?
Oh, I like the repairs. I like when the stuff goes wrong and we got to fix it, and we got to figure out how to fix it. That's the stuff I love.
It's always chaos equals cash, right?
Oh, that's a nice little side point, I guess, too. But I love the broken stuff and getting in there and fixing it. That's great.
Well, I think That's really good. I do enjoy that as well. And for me personally, and I think for you, Scott, as well, not every repair is the same, and it actually challenges your thought process and your understanding of what the hell is actually happening, not only in the codes but also in the vessel. And like, how can you provide a sound repair plan if you are providing that? You most definitely will be providing input as an inspector, right? But like a lot of larger facilities, there's already a team designated for repairs, and there are a bunch of engineers who just eat this up, and like they're quick with it. Like they know what the heck they're doing, hopefully most of the time. Like the ones we've had experience with, like it's pretty impressive. But as the inspector, you are there to kind of give code guidance as well as experience guidance and any recommendations. And then obviously when you have a good team together, like you guys can put in a repair plan together and execute it really well. And obviously the trades, like having them involved as well, right? Their quality department and even their foreman supervisors.
Yeah, I think that's a good point not to overlook, because those are the people that fix this stuff all the time. So they got great input. And I mean, we're there as the inspectors to provide our input and give our guidance. And you want to check what the engineers are doing sometimes too. Make sure they're applying the right codes and the right code additions and things like that. We're not going to check their math work or anything like that, but you want to make sure like everything's being applied properly, and you want to pull in some past experience too, especially, those contract guys that bounce around to different sites who may have seen these same repairs over and over again on the same type of equipment with, a couple different variations of things that worked and things that didn't. So that's kind of the advice you definitely want to provide, how different materials react to things like that.
Yeah, no, definitely. Kicking back into our circuitization, basic requirements of your circuitization are going to be definitely your process, like what's happening, your materials of construction, pressures, temperatures, even the phase of the medium in there, I guess.
I was grasping for what to say there too. Yeah, the medium phase, I guess, fluid, vapor,
right?
Liquid.
And sometimes, like Scott touched on just a couple minutes ago, you could have two phase flow where you have some stuff condensing along the upper portion of the pipe, and you're getting some dew point corrosion, which is kind of a real term, but not a real term, but essentially refers to, water or some sort of condensation forming within the pipe that is typically acidic, and it's going to start causing corrosion predominantly on carbon steel piping, right? So that's kind of like dew point corrosion, where you can think of exactly like when you wake up and there's dew on the grass. The moisture is condensing and collecting, and it might just fall into the process stream and be diluted, or it can be super corrosive where you might need some condition monitoring locations along the upper portion of the pipe, right? And that's where your process guys and operations actually really come in.
Yeah, that's exactly right. That getting back to the point of not forgetting the top of the pipe. I mean, you can have corrosion on the top and the bottom in the same system, depending on what's going on in there. I mean, there's one very big disadvantage with piping systems over pressure vessels, and that is you can't go inside and internally inspect them.
Yeah.
That's why there's so many CMLs, and that's why we have to scrutinize it to all these different NDE types, because we can't get in there and have a look. We have no idea what's going on inside there. So, that's one way to think about it. Has anybody tried to fit inside a piping system? For the most part, you can't get into them.
I will actually admit that I have been inside a piping system. It was I think it was like a 60 or 72 inch line in a gas plant, a huge gas plant in BC, actually.
They used you to pig the line, or what were they doing?
No, you know what?
Wrap you up in
we
paper
could probably
towel
go into a little side note here. It was actually pretty interesting. We had gone in the pipe, and we were walking through it. We were probably like freaking 25 to 30 meters in it already, and the site alarm went off. And what ended up happening, like we didn't know we were in a freaking sulfur, it was some sort of a huge sulfur line or something. I don't remember exactly. It was, but
scary.
The plant alarm went off and we got out of there. And as we were going to our muster station, what ended up happening was a shear pin on a JLG man basket had broke on the knuckle, and the basket was actually inverted, and the two guys were hanging.
Guys in there.
Yeah. Oh yeah.
Wow.
Yeah. So that was, I don't know. It's just a kind of something you don't see every, like, when was the last time you see these shear pins on JLG's break, right?
Yeah, I don't think I've seen that up close, maybe on a safety video or something, but I can't say I've ever seen that happen. That's a nice story about the internal inspection on the piping, though. I guess there's the odd time, like I could say I've been inside one or two transfer headers off getting back to the heaters again. I mean, the ones that aren't refractory lined, the heavy alloy ones, you go in there on a skateboard or something, you get drugged through it, that type of thing. But yeah, for, 95+% of your piping, when you look around your facility, it's all stuff you can fit your arm around, so you're not getting in that. So that's just something to keep in mind, right? It's hard to know what's going on inside there, so that's why we do all this UT and X-ray and things like that. Ultrasonic, if you don't know what UT is.
Yeah. Well, I'm actually working in fab shops. They would stuff me in like 18-inch pipes, like to just go look at high-low and stuff like that, or
check out you got those big OLEDs or something like that. Those type of things. Yeah.
Oh yeah. No. Wow, yeah, I'm a stout 5'9", like 157 for people, I guess, listening. So
you're made for the piping internals, I would say.
Oh man, yeah, just like a cartoon, right? Like Bugs Bunny going through the tubing or something. So essentially, circuitization, you want to break it down by your process. You're going to want to look at any potential damage mechanisms. If you don't have access to process engineers or operations to kind of tell you what the heck's happening in there, a good resource is actually API 571, right? It's the recommended practice, damage mechanisms affecting the refining industry. I think that's the
I think that's exactly it. Very, very good resource there. You can, especially if you know what your mechanism is, then you can look it up and you'll find a lot of detail in there and kind of a bit of a past history type of thing. A bit of an encyclopedia, I guess. It has kind of information that changes over the years based on what people find and submit and that type of thing. So it is kind of a nice document created by the industry.
Yeah, and actually at the back of API 571, they actually have generic, I don't know if they're not entirely like process flow diagrams, but it's essentially a flow diagram, and it will actually, of generic units, right? If you have some weird frickin' thing, some unit that's making some one-off product, it's probably not going to be in there, but you also will also have process engineers at your disposal. But like for your typical units, FCCs, crude vacuum units, maybe some desulfurization.
Yeah, sulfur plants,
hydro treating units. I know those are different, but I'm just kind of going with it. Hydro treating units, stuff like that. In the back of the book, they actually have flow diagrams, and it'll actually show you where the most commonly damaged mechanisms are kind of spread out through there, right? And that's a good starting point to at least get something going and kind of start refining your inspection methods, your frequency, likelihood even too, depending on what materials you have. So just keep that in mind. Like I said, we're freaking nerds at this, and before, I don't know, like starting out with I did start out with a small inspection company, so we didn't always have access to all the codes, especially in PDF form. So I would literally bring a binder, 571 binder.
Oh yeah, nice.
With me.
Paper style.
Yeah. And we would sit there and, pre-turnaround, we'd see which vessels we had. We would see, what are the possible damage mechanisms that might affect it. And we would actually make it a game, I guess, with the other nerdy guys I hung out with. But you need to know what you're looking for to find it all the time, right? And to properly assess it. And sometimes you might see another damage mechanism, which you didn't expect, which you can then report to the owner user, and that'll help them with a path forward with their integrity plan.
Update their IMS program or their corrosion documents and whatnot. But yeah, it's a kind of an interesting game you play there. That's a good one to talk about, I think, when we get back into our turnaround, pre-turnaround, wherever we're at with that. But that's definitely something, you want to, if the information's available, you want to become very familiar with the history and what's going on there before you go in and inspect something, for sure.
Yeah, no, definitely. Scott, how much more do we want to get into this? We got circuitization. I think that is a good air quotes high level kind of thing. There is some more things that you will want to look for in there, and we can. I think getting into that a bit more would be worth it.
I think we do an episode on that. Maybe not a part 3 because that's not so much into the life cycle. That's getting detailed into some section of the life cycle. But yeah, I would say we'll at some point bring up an episode just right on circuitization, maybe go into some damage mechanisms and things like that. I think that'd be easy to talk about for an hour.
That'd be really fun. And I'm trying to corner a corrosion engineer to come on and talk with us. He's a bit skittish, so we'll see what we can do. The last few notes we have on our I guess, point board or our electronic tracker. It's not really electronic, but
it's not electronic at all.
We took digital information and wrote it on there, so
we went backwards in technology.
Yeah. Mix points and soil to air interfaces. Personally, I think soil to air interfaces are extremely overlooked.
Oh, absolutely.
And again, that could be its own freaking episode. I'm sure we've already bored you enough, so we don't need to get into that. Mix points are super critical. That's going to probably be its own episode.
Yeah, don't forget about your mix points and even injection coils and things like that, right? You're going to have pretty routinely, X-ray shots or RT shots and things like that, right? Just to make sure they're still in place and what's going on there. But I mean, a lot of facilities will treat a mixing point like its own piece of equipment, and it gets heavily scrutinized, and it's on a turnaround cycle with the equipment in the unit. And, you'll do all kinds of, phased array automated UT, you might throw some X-ray at it, a bunch of surface ND, all kinds of things like that. And it's not uncommon to have a lot of cracking mechanisms or something in there that's, it's unrepairable and you end up cutting these things out. I don't want to say routinely like the same one all the time, but when I say routinely, I mean like the odd mix point here and there. It's not uncommon to see in turnaround. So that's something you want to scrutinize pretty heavily and even monitor on the run what you can. They typically run quite hot, but it's something you definitely don't want to overlook for sure.
Yeah, and I guess kind of to prevent us from revisiting this in another episode, a mix point would be where you have two different process streams converging and mixing, and it doesn't necessarily have to be two different products. It could also be two different temperatures. So you can also have like a thermal mix point where you'll have thermal shock of the pipe at the mix point, which can cause issues, right?
That can almost be worse sometimes, really, as compared to the process mixing.
No, for sure. So when we say mix points, it is exactly what it sounds like. And when Scott's talking about an injection quill or something like that, this actually might tie back to tubing. Is you may have chemical injection or something like that. And it's not typically run with small diameter piping. You might have something like instrument tubing or something, which is totally fine. But that is a use for tubing aside from what our initial kind of impression of it was, instrumentation,
steam tracing
and steam tracing and stuff like that, right?
Yeah, and it's essentially part of the piping system at that point because it ties right into it and it's not isolated. It's there to inject into the piping system. So you should be scrutinizing it the same as you would the piping system for sure.
Yeah, and ironically, this is like 99% of the time is that the chemical injection tubing is like haphazardly ran, and it's not it's got no supports and like. It just looks like a disaster, right?
I would say that's all of the time, not some of the time.
So that is something that you definitely want to look for, especially it's usually carrying some sort of toxic chemical to help mitigate something within the process. And like, your
plant operator doesn't want to be breathing that in or have that splashed up in his face. So, I mean, you got to scrutinize that just like it's a piece of piping, and it really essentially is.
Yeah, and, despite contrary belief, stainless steel tubing and stuff does corrode if given the right conditions, right?
Oh, yeah, stainless steel is susceptible to a lot of different things. I mean, it is pretty resilient. Yeah, that's a general statement. But, yeah, there's a lot of things that can eat through stainless rather quickly. So, yeah, you want to be aware of that.
Yeah, to be honest, I was hoping to get a bit more into the circuitization of this episode and stuff like that. That might be a third
You can
part
see
of
the
this.
disappointment on your face.
Yeah, it's my favorite. It is literally my favorite thing to do. Like,
That's an hour, though, I think. I think that's an hour.
yeah. So, I hate to lead you guys on with that. Like, the first 20 minutes was just a recap of episode 1, but like it was some important information that we needed to go over. So
I feel bad that this is ending. It's like you have so much inside. You're trying to get it all out.
I know, but I feel like horrible. We've already bored people for the last hour and
I feel like you're
20
getting ripped
minutes.
off or something. You need another hour.
I could sit here all night and just talk smack about inspection. I love it. Man, what was that? So I hope you like the intro. Scott and I were talking before. We kind of want to do an intro, so Scott threw a stab at it. I think it was pretty good.
I'll have to listen to it again. I blacked out. I don't remember what I said.
So for sign-offs, I think we still need to come up with a sign-off. Actually, I put so much effort into trying to take notes for the episode, I didn't really think of one. But I really like the one you used last time, and that was cue the music. So, Scott, yeah, what do you think? Cue the music?
Cue the music. That's not bad with maybe talking about PSVs for way too much time. Maybe don't forget to check your set pressure.
Yeah, no, definitely. Thank you guys for listening. If you do listen, don't forget to share. Send us some comments. We've got some great feedback already. We appreciate you guys even taking any time out of your day to listen to what the hell we have to say. But thanks a lot. Share it. Subscribe. Let us know. And let us know if there's anything else you guys want us to talk about. And I guess cue the music.
Cue the music, yep.